Caroline has 20 biscuits in a tin. She has 12 plain, 5 chocolates, 3 ginger. She takes at random 2 biscuits from the tin. Work out the probabilities that the 2 biscuits were not the same type. So I'm going to draw a tree diagram for this, just to help me organise myself and to show all my working out. So the first biscuit could be plain, could be chocolate, could be ginger. The probability that it's plain is 12 out of 20, because there are 12 plain biscuits she could have picked out of 20 in total. The probability of it being chocolate, she's got 5 chances out of 20 of it being chocolate, and she's got 3 chances out of 20 of it being ginger. And just make sure as you're going along that these 3 probabilities add up to 20 out of 20, which we can see they do. 12 plus 5 plus 3 is 20. So there's the probabilities for the first biscuit. For the second biscuit, if she took a plain out the first time, the second time she can take plain, or she could take chocolate, or she could take ginger. Now, assuming that she didn't put the biscuit back, the first biscuit back, that would mean that there's only actually 11 plain biscuits left now for her to take another one, and there's only actually 19 biscuits in total. So the probability of the second biscuit being plain, given that she's already taken a plain biscuit out, is 11 out of 19. The probability that the second biscuit is chocolate, well, remember there were 5 chocolate biscuits in the first place. She took a plain out, so that means there's still 5 chocolate biscuits left. But note, there's only 19, because remember she took a plain one out. And the probability of being ginger, the same logic, would be 3 out of 19, because there's still 3 ginger biscuits left if she took a plain one out the first time. So again, make sure these add up to 19 out of 19, or 1, which they do. 11 plus 5 plus 3 is 19 out of 19, so that adds up to 1. So these are the probabilities of the second biscuit being plain chocolate and ginger, given that she took a plain out the first time. We can repeat that process if she took a chocolate out the first time, so it could be plain, chocolate, ginger. So given that she took a chocolate out the first time, there's only 4 chocolate left now out of 19. So the probability of the second biscuit being chocolate as well is only 4 out of 19. Plain, there would still be 12 plain left. Remember, there were 12 of plain at the beginning, and she took a chocolate out the first time, so that means there's still 12 plain left. And ginger would be 3 out of 19. And finally, if she took a ginger out the first time, again, she could get plain, chocolate or ginger the second time. Ginger, there were 3, she took 1 of them out, so there's only a 2 in 19 chance of her taking a ginger the second time. Plain would be 12 out of 19, and chocolate would be 5 out of 19, because remember she took a ginger out the first time, so the plain is still 12 and the chocolate is still 5. And again, make sure these still add up to 19 out of 19, which they do. Right, so that's my tree diagram. I now want to use that to work out the probability that the biscuits were not the same type. So that means plain and chocolate, or plain and ginger, or chocolate and plain, or chocolate and ginger, or ginger and plain, or ginger and chocolate. So I could work out all of those and then add them together. But that's quite long. Instead, I'm going to do a bit of a shortcut. I'm going to work out the probability of if they were the same. So I'm going to work out the probability of the ones that I don't want, and then I'll take those away from 1. And that will be the same as working out everything else. A little bit shorter. So plain and plain. So we've got 12 out of 20 times 11 out of 19, which would be 132 out of 380. So that's the probability of a plain and a plain biscuit being picked. Chocolate and chocolate would be 5 out of 20 times 4 out of 19, which is 20 out of 380. And then ginger and ginger would be 3 out of 20 times 2 out of 19, which is 6 out of 380. And so like I say now, if I just do 1, because that's all of these together, take away these, so take away 132 out of 380, take away 20 out of 380, take away 6 out of 380, that will tell me the probability of all of these remaining ones, which are the ones where they were not the same type. So let's do that. There we go.